Welcome to qnawire.
So in this ballistic pendulum experiment, so you can set it up like this. So you have a projectile that's moving to the left, and then you have a pendulum that's hanging over there. And so this is a situation before the collision, and then after the collision, you have a scenario where you have a pendulum with a ball inside it that now swings up to a certain height here. Um, so let's just assume so this is setting up the problem. So you're told that the change in height here is around 8.68 centimeters. Um, and you want to calculate this V1 here, the initial velocity of the projectile. So the first things first, we want to work backwards until we get this velocity, and we have several tools we can use for that. So the first one is realize that since there's a change in height over here, there is a gain in potential energy from the loss of kinetic energy. So from energy conservation, we can just say that half mv squared is equal to mgh, where m here is the mass of the pendulum and the ball together. But since these are common in both sides, I'm just going to go ahead and remove them. So this means that V is actually just going to be equal to the square root of 2 times G times H here. So this, you can annotate it as big V, because that's the velocity that the system has immediately after the collision. So you have the velocity immediately after the collision, and now you want to work backwards to the velocity before the collision. And now you know that since this was a collision, the initial momentum is equal to the final momentum here. So what that means is now I can write my equations of conservation of momentum as follows. So I have m1 v1 plus, the pendulum is now moving, so that momentum is 0, should be equal to, now I have m1 plus the mass of the pendulum, this multiplied by the velocity of the whole system. And that velocity we've already found as the square root of 2gh, right? So now to find this v1, it's just going to be equal to m1 plus m, which is big M, which is mass of pendulum, times the square root of 2 times g times h over m1. So if you now plug in the masses, so if you have m1, that's equal to 68.8 grams. Big M is 263 grams, and H is 8.68 centimeters. So now if you plug in these values into this formula, you will see that your V1 is actually 6.29 meters per second. So this is how you work backwards from the ballistic pendulum side of things. But now they want you to use projectile motion in the second part. So you can set up the problem as a projectile leaving this horizontal platform with V1, and it goes, then it lands a certain distance. So in this case, 257 centimeters away from where it started. but it also gone through a vertical change in distance of 85.3 in this case. So now you can use kinematics to figure out the initial velocity v1 back here, because you know that the velocity in the x doesn't change because there's no acceleration, deceleration in the x here, but the velocity in the y has to change because things being accelerated by gravity. So the velocity in the x direction, which is in this case v1, which is what we want, is actually just the distance that it has moved over the time. So we know what the distance is. The distance is 257 centimeters, but so we can change that to meters by just dividing by 100 in this case. So this is 100 over t. So now our job is to find this t here, and we can look to the y direction for that. So we know that since there's acceleration, it's constant acceleration. So that means that the change in y is actually equal to vy initial times t plus half gt squared, because the acceleration is coming from gravity here. The initial velocity in the y is clearly 0 because this thing is moving in the x only. So that goes away. So now we can see that 85.3, which is the change in y over 100, because that's in centimeters, this is equal to half gt squared. So already from here, we can now see that we can actually calculate the t as the square root of 2 times 85.3 over 100, or divided by g. And then, so now what we want is to plug in that t in that place here to find v1. So once you do that, you see that v1 is equal to 6.16 meters per second. So these are different because there are 2 different experiments, and they are all subject to different kinds of errors. So in this case, you might have measurement errors for these distances here, and you also have air resistance as well, as this thing flies through the air. And then here, you could have some friction on this pendulum swing here, and also air resistance is involved. But there are different kinds of processes that can take away energy from your system. So in either case, you're going to have 2 different velocities if you calculate them using 2 different experiments.